Welcome to our lesson on the scientific method. The first thing we're going to talk about is the concept of iteration. Iteration, according to the Merriam-Webster dictionary, is the repetition of a process, so the repeating of an activity, in order to generate a sequence of outcomes. We're not looking for one end result, we're looking for several. The sequence will approach some endpoint or an end value, which means we're doing this for a purpose. We have a goal in mind. Each repetition of the process is a single iteration, so one step of the process, and the outcome of each iteration is the starting point for the next, which means this is a repeating process with the idea that we're going to get better and better and better every time. How does this apply to the scientific method? The scientific method is not a lab or an experiment, which is probably what some of you believe the scientific method really is. So that lab report that you write every so often with your title, your purpose, your hypothesis, materials, all that kind of stuff, it's part of an iterative process and it helps us understand the world around us, but it is not the whole process. Experiments are simply a piece of that puzzle. We're going to move on in 3, 2, 1. Let's look at this cartoon for a second. John is saying he likes the flavor of this new tea-flavored coffee, and Liz asks, why don't you just drink tea? And Garfield points out that logic has this effect on him where he gets really confused with the idea of just drinking the tea instead of having coffee or tea-flavored coffee. Every now and then we need to challenge how we think, and sometimes that challenge is hard for us, but it's in that challenge that we actually get better with what we're doing. Let's see how this works. All right, so this slide is a drawing. It's a flow chart. I would recommend waiting until you see most of this slide before you start actually writing it down. So you're going to be able to pause this movie wherever you need to. The normal starting point in any process is observations. We notice something, we make observations, and that leads to thinking about questions and trying to understand what does that observation mean. Once we have that idea, we're going to formulate a hypothesis or an idea of what we think is going on. So we've got some questions, we come up with some ideas that we think could be going on. Based on that, we usually develop what we call a testable prediction. So if something is going on, we think something is happening, so let's develop an idea where we can test our predictions. From there, we're going to actually do it, gather data, and so these two steps in terms of developing a testable prediction and especially the gathering data to those testable predictions, that's really what you guys think of as a lab. But that's a tiny portion of the process for the scientific method. From there, we refine, alter, expand, or even reject our hypothesis. So it's entirely possible that the original hypothesis is wrong, and that's okay. Because in the scientific method, the goal is to build a body of evidence for how the world works. So in science, you can publish information that says this does not work, and that's actually valuable because it means nobody else will do the same thing. After we've got a refinement, an alteration, expansion, or rejection, we develop new testable predictions, we gather more data, and we can go around and around and around in that loop as many times as we need to in order to refine testable predictions and come up with ways of gathering data and coming up with refinements to the hypothesis. Once we've got that hypothesis pretty well staked out, we develop what we call general theories. Those general theories come from that hypothesis and the refinement of that hypothesis until we've got a pretty good handle on what's really going on. The great thing about that general theory that we've just developed, that's going to lead us to making, new observations. And once we make new observations based on that general theory, we're able to move on from there and develop even more interesting questions. So yes, this cycle goes around and around and around, and it's got a loop and a subloop, and this is just one way of presenting it. But the process, the purpose of this process is to help us understand how things work in a better and better and better understanding. So if you haven't copied it down yet, this is a good point in time to pause the movie so you can get this flowchart down. And we're going to move on in 3, 2, 1. Let's talk about what observations can be. First of all, they can be qualitative using your senses, like a color change, or using tools to extend our senses, like a piece of technology that will actually measure color beyond the visible spectrum. It can be quantitative, which means it's a number associated with it, typically with a unit, like a mass. Observations build what we refer to as empirical knowledge. Empirical knowledge is an understanding of how something really works. It is not based on theory, it's based on lab experimentation, but it can be used to develop a theory. And generally speaking, empirical knowledge is better than theoretical knowledge. Theoretical knowledge is what we think we know based on a theory, but empirical knowledge is based on what we've done in a lab. Occasionally that empirical knowledge is wrong because we've missed something in an experiment. And if we've missed something in an experiment, then our empirical knowledge can be refined once we find those mistakes. Theories are simply a set of ideas that explain a bunch of observed behavior based again on that empirical knowledge. So when in doubt, empirical lab-based knowledge is the best. Anything that we call a law in science are simply theories that have stood the time for centuries, don't have any contradictions, and therefore we can say that this is a law. There are some laws that have some exceptions. Okay, so mass can't be created or destroyed is the law of conservation of mass. However, Einstein's E equals mc squared says that under special circumstances you can take mass, and if it's converted into energy, then yes, you can destroy mass, but those are rather unusual situations. We're about to move on to the last slide now. The next step. Attached with this or connected with this should be two worksheets. One is a scientific method activity worksheet, which is a normal handout with a series of instructions and some questions and a place to record some data. And you're going to have a separate instruction page on how to fold a paper frog. You're going to complete the activity. If you don't happen to have a printer at your disposal, that's okay. You can look at both of those documents using your phone or your computer. And when the time comes to complete that scientific method activity, if you can't print out the worksheet that I've got for you, that's fine. All you've got to do is put the title as provided in that activity page, put your name on the top of it. You're going to record your hypothesis next. You do not need to recopy all of that information. Please don't do that. Just record your hypothesis, make a chart and record your observations, and then complete the analysis questions that are on the second page of that method activity. Thanks for watching.